So
here's our drive hub that we tie into to make the table turn. There are 4 1/4-inch bolt holes at exactly 90 degrees apart. Okay. Now we have ready to put a new key in this.
Yeah. It's going to shoot up.
Which I should probably do, because that actually, the table locates on that key. And our dies also locate on that key. This would not be necessary if these holes were perfectly aligned, but they're off a little bit because the equipment that we have here isn't, in my experience, is not enough that I could get those exactly 90 degrees apart. So in order to make things go quicker, we just
Okay.
I just set that.
So all the structure here essentially supports. There's spacers, so there's the there's the bearing, and what is that's a spacer there, or
yeah,
that's
that
collar,
holds the
lock
shaft on location.
Okay.
This one does. That's just a spacer, to lift the table up off
to where
the platform up above the channel.
Spacer, and then that's the
and then that's
plate,
your collet, and that's keyed on the shaft as well.
And you did the internal keyway there, or that was already keyed?
That was already in the shaft. We ordered it that way. But you can do, but you can put that shaft in a mill,
such
as that, and make that keyway.
Did you make the keyway on the inside? So you cut this from a flat sheet?
Cut this. Yep, I used a plasma cutter to cut this.
And then you put the keyway in.
Then I just filed the keyway in there.
Oh, you just filed that?
Yep, I just filed it by hand. And then
or you could use a brooch, right?
Yes, you can. That's a more effective, more precise way. But for what we're doing is, precision isn't really an issue in this part of it.
Yep. Okay. And this you made from a stock of aluminum?
Turned this out, yep. Just turned this out on the lathe. And then made this in the mill. And then bolted it in.
So this piece of aluminum you just milled out completely on the mill?
I cut it first with a band saw to get it to the rough shape, and then finished it with the mill, and then to get it smooth like this, use that belt sander to make these surfaces smooth.
On the mill, how do you get that angle? You just by hand? You just did it totally by hand, or was there some jig?
Yeah, no jig.
Just by hand.
We're not doing anything mass production, so it was just something that, if you're gonna make a whole bunch of these, you'd want a jig, and then you could, then you can just put it on even on a rotary table. You could put it on something like that belt sander with a shaft, and then just turn it.
Yeah.
You're limited.
Why aluminum?
To your imagination. It's what we had.
Okay, so that could be steel.
Some of our other dies are made out of synthetic materials. And that's all one piece.
That's plastic or something?
Yep, it's a synthetic. It's a material used to simulate wood.
Okay.
And this, I just took a compass and drew my circle. So you can still see the pencil mark on the bolt hole diameter.
Yeah.
And then I drew the bigger circle and then the elliptical part so that we come around the outside of that first wind in the coil.
Mm-hmm. And you have different ones for this. This is for 1/2 inch.
Yeah, this is for 3/8.
Uh-huh.
See, there's 1/2 inch. There's 3/8. There's 1/4 inch. That's made out of nylon. And what we did is we went to an auction, and there was a whole bunch of this stuff that they had for stock, raw stock,
mm-hmm.
and they just sold it bulk.
Okay.
And we got $4,000 or $5,000 worth of raw materials for $150.
Uh-huh.
Sometimes you luck out in things like that.
Mm-hmm. Mm-hmm.
So.
Okay.
If you're interested, we have plenty. I'll let you take some home with you.
Mm-hmm. Yeah. Yeah, excellent. Is there, let's see.
There's something else we made. I think I just used that to do some hairpin turns.
That's also...
These were actually made for another table that someone brought here.
Uh-huh. And you started the pipe inside like that?
Yeah, you make that first bend on that bender, and put it in here, and then draw it around like that.
Yep.
This is just a copy that we made.
So you basically took, for this, you just took the mill under manual control and you just milled it out.
Yep.
Uh-huh. And CNC would get it really nice and straight.
Oh yeah, if you used a CNC or a laser cutter.
Yeah.
You know, they're even doing things with high pressure water now. Now we
water
needed
jet.
On our Keen boiler over here. I actually took these and had them made by a fab shop.
Uh-huh.
Because we needed a precision diameter in here, a precision radius.
Uh-huh.
So,
now how do they do that? Is that a grinder?
I don't know.
Mm-hmm.
I don't know how they cut that.
Okay.
And they're CNC. They've got 100 CNC machines there that they got going around the clock, and it was more cost effective to just have them do it than for me to do it here at the shop.
Uh-huh.
Because it just, I'm working with some pretty basic stuff here.
Yeah.
We have been we fabricated this boiler, every bit of it ourselves, with that coil winder right there. And we have all the way from 1/4 inch up to 1 inch tubing, and it's all black pipe, and it's all schedule 80 because we're running well over 500 psi inside this thing at any given time. In fact, ideally you want to run at about 800 psi for that engine that's in that car, and 800 degrees, and that's what you try to keep your steam temperature and steam pressures at.
Mm-hmm.
So, but the superheater down here is schedule 160.
Oh wow.
And we did all of that on that winder right there.
Still on the same winder, okay.
Yep.
Mm-hmm. So that could go up to 160, schedule 160 for 1 inch?
Yes.
Mm-hmm.
It actually handled it quite well.
What we're doing for ours, that's schedule 40?
That's schedule 40.
Okay.
Because you're going to be running lower pressures and lower temperatures.
Yep.
On an engine as small as yours, you don't need, and especially that one that Gary has, is designed to run at lower pressures and lower temperatures.
Yep. Okay.